All right, guys, so this morning we're going to be talking about the review for the final. Now, we're having some technical difficulties while it tries to sort itself out. I'm going to go ahead and try and get some of these problems recorded and ready for you to go. So they're not going to look exactly like they look at on the math program, because the math program's not working right now. So I'm kind of just copying off of the printed version of what I've got. So number one says that Sid needs 0.4 meters of canvas, and canvas costs $10.79 per meter. So how much is he going to spend? Well, if it's $10.79 and I need 0.4 meters, I do $10.79 times 0.4, and I'm going to get $4.32. Now, I'm not going to get exactly $4.32, but it's going to round to $4.32. Remember, when you're rounding money, you always round to the nearest penny. So that's going to round to 32. Okay, so number two, if your car gets 31 miles per gallon, how much does it cost to drive 440 miles when gasoline costs $2.60 per gallon? So this one, we actually have a few steps going into it. I know that my car gets 31 miles for every gallon, and I'm going to go 440 miles total. So the first thing I'm going to do, I'm going to take 440 and I'm going to divide it by 31, because that's going to give me the number of gallons that I need. And then I can figure out the cost. So 440 divided by 31 gives me 14.19. Now, I'm not going to round yet because I'm not quite done with the problem. I'm not going to round that to 14 or 14.2. I'm going to leave it 14.19 because that's how many gallons I need. And each gallon, so I'm going to take that number, and if each gallon costs $2.60 per gallon, I'm going to take that answer and I'm going to times it by 260. And I get 36.903. So $36, and that's going to round to 90 cents. So $36.90. Now, problems like this where you have that decimal partway through the problem, remember not to round until you get to the very end. Try to keep as much of the number there as possible. Sometimes when you start working with big numbers, that rounding too early can throw off your numbers later in the problem. All right, so number three. Complete the following sentence with a power of 10 greater than 1. So it says that a square meter is blank times as large as a picometer. So I'm comparing meters and picometers. So if I look at my metric units, at my prefixes, a meter is 10 to the power of nothing. A meter is just 1. And a picometer is 10 to the negative 12. But if I read the question carefully, it doesn't just want a meter. It wants a square meter and a square picometer. So I've got to take that 1 and square it, and I've got to take that 10 to the negative 12 and square it. So what I end up with is 1 over 10 to the negative 24, because I have to do 2 times that negative 12. Now what this means is if I bring this 10 to the negative 24 to the top, that becomes 10 to the 24th. So in my answer, it's asking me, it gives me the 10, and it wants to know what exponent goes up there. How many times larger is it? Well, that's your exponent right there. That 24 would be your answer. 10 to the 24. Okay, number 4 is something really similar. Number 4 wants you to do the same thing, but it wants you to compare a cubic meter. So it wants you to compare meters cubed compared to, on mine, it's micrometers. So micros cubed. Well, again, meters, the unit for meters is just 1. The unit for micrometers is 10 to the negative 6. But both of those have to be cubed because they're cubic. So this becomes 1 over 10 to the negative 18. And when I move that to the top, 10 to the 18th, that means that it is 18 times as large as the cubic micrometer. Or 10 to the 18th times as large. It's going to give you a 10 with a blank right here. You're going to put in 18 because it's 10 to the 18 times as large as a cubic micrometer. All right, number 5. Now you'll notice some of these that we do twice for a reason. So make sure, especially those ones, you need to know how to do everything on the review. But if there's 2 of them in a row, then you really want to make sure that you know how to do it. Number 5 says that it wants you to write a number, the first number, as a percentage of the second. So what that means is my first number goes on top, my second number goes on the bottom. If I'm writing the percentage as the first number, what percent is it of the second? Remember, our of always goes on the bottom. So first over second. And in my example, it says that a candidate won 302 electoral votes out of a total of 506. So it wants a percentage of the first to the second. So I'm going to put 302 divided by 506. I put that in my calculator, 302 divided by 506, just like this. And it tells me 0.5968. So 0.5968. And it wants my answer written as a percent rounded to the nearest tenth. Well, if I write this as a percent, that's 59.68%, and it wants me to round to the 10th place. So 59.7% would be my answer. Please don't miss questions on the final because of rounding. Guys, all of this work that you're doing, all of this studying that you're doing, and then if you get sloppy at the end when you have to round or you get lazy, it's not worth all the work that you put into it. So take your time as you're putting in the answer to make sure that you're using the right rounding and the right form so that you don't miss the question when you should have gotten it right. All right, number 6. Number 6 says same thing. Express the first as a percentage of the second. So I'm going to take my first number and divide it by my second number. And in this case, it gives me a different situation. It says full-time salary for men is in a year was 42,300. And we don't know what men it's talking about. The full-time for U.S. women was 34,700. So if I write that as a percentage, the first of the second, I would do 42,300 divided by 34,700. And I get what? 101.2190. So 1.2190. Now, don't panic when you see that 1. That just means that my percent is over 100, which it should be because my top number is bigger than my bottom. So if I write this as a percent, it's 121, and I'm rounding to the nearest, tenth again. So 1.21, or 121.9% would be my answer. Okay, number 7. Number 7 says to find the scale ratio. So it tells me that 1 millimeter represents 100 kilometers. So what I'm trying to do here is it wants to know what the ratio is. Basically, it wants to know how many millimeters are there in a kilometer. Okay, it wants to know how many millimeters are there in a kilometer. And there's a lot of different ways that we've done this problem. A lot of you can just kind of work your way through this, but basically a millimeter is 10 to the negative 3. And a kilometer is 10 to the 10 to the positive 3. So to go from millimeters to kilometers, I'm going up. The units that I'm going up by I'm going up by 10 to the 6th units, right? Because I'm going from -3 to +3. So I'm going up by 10 to the 6th. And that will take me from millimeters to kilometers. But it's not just 1 kilometer, it's 100 kilometers. So I'm going to do 10 to the 6th, but then I'm going to times that by 100. So my answer would be 100 with 6 more zeros. 1, 2, 3, 4, 5, 6. So that means my scale ratio is 1 to 100 million in real life. So 1 millimeter on the map represents 100 million millimeters in real life. And I don't know how often you would represent, I don't know, maybe if it's a map of like the globe, 1 millimeter is going to represent 100 kilometers. That's a pretty big scale for a map. All right, so number 8. Same idea, the scale ratio, but it wants me to go from 1 centimeter to 5 kilometers. So again, centimeters is 10 to the -2. Kilometers is 10 to the 3rd. So I'm going up by 10 to the 5th. That's how much I'm increasing. But it's not 1 kilometer, it's 5 kilometers. So I'm going to put a 5 in front. So 5 times 10 to the 5th is 5 with 5 zeros. So that's 500,000.